Hi everyone, I'm here with Ian Graham, one of our principal engineers, and today we're going to be talking about the RF performance advantage you get when you choose Tait. So to get us started, Ian, could you just explain what RF performance is?
Yeah, no problem, Evan. So if you just start by maybe just explain what RF is to begin with. If you start thinking of, say, a simple telephone where two users are connected by a piece of wire, you have a direct electrical current flows between the microphone at one end and the speaker at the other end. And the strength of that current is varied in sympathy with the speech vibrations that the microphone picks up. And obviously, if you take the wire away for wireless communication, that won't work. So instead, what you do is apply a very high frequency alternating electrical current to an antenna, basically a conducting rod, and that generates an electromagnetic field. It weakens with distance, but you can pick it up a long way away. The strength or frequency of that field is varied in sympathy with the applied speech to convey the information. So in any radio communication system, there'll be a transmitter that superimposes the information to be sent onto the RF carrier wave and sends the information. Then a receiver, which picks up the minute remnant of that transmitted electromagnetic field and extracts the information that was sent.
Okay, so that basically describes RF performance. So to describe how well the transmitter and the receiver carry out these roles, I see a lot of performance specifications on data sheets. Would you mind just explaining what some of those mean before we get into the actual specifications?
Yeah, absolutely. So if we look at some of that, we'll look at some of those performance specifications, understand what they mean, and then look at their effects on a radio system, a real radio system, in ways that are important to public safety or mission critical clients. Things like coverage, reliability, and cost. So the RF performance of all base station mobile or portable radios is quantified by a set of specifications usually given in dBs, decibels. One set of performance specifications describes the transmitter performance, and there's a second set that describes the receiver performance. For some of the performance specifications, it can get confusing because a larger number is better for some and a smaller number is better for others.
Okay. Kind of like golf or tennis or, yeah, gotcha.
So there are minimum acceptable performance specifications prescribed by regulatory authorities in the countries to which we sell, so like ETSI in Europe and the FCC in the USA.
Okay.
So meeting those levels of performance is mandatory, but Tait often exceeds those, and that gives some important benefits in terms of system cost and reliability. Some RF performance specifications are more important than others to the real-life operation of the radio system. So this video will explain what the most important RF specifications are and whether a smaller or larger number is best, and why these give real-life benefits such as lower system cost and improved reliability.
Okay, great. So now we'll take a look at RF specifications around the transmitter.